Right, so the questions I'm doing now then, I have actually linked in the Google Classroom. You can see the exact questions I'm using here, but I've summarised the key information. These things here, which were given in the question, I put in red in my own way on the diagram, so I can use them as I'm going along. Okay, the first question should be fairly straightforward. It's asking me to get from M to N. So I think I'll go M to P, then P to O, and then O to N. So that's the wrong way along 2B, the wrong way along 4A, and then the right way along 6B. And if I simplify all of this, then 6B minus 2B is 4B minus 4A. Okay, great. Next, one more time. X is the midpoint of MN, and Y is the midpoint of QR. Okay, let's put these on here roughly then. So that means Y is about there. X is about here. All right. Prove that XY is parallel to OR. All right, then what I've got to get from X to Y then, I noticed that it would be useful to use this road at some stage. So before I work out XY, which is ultimately what I'm trying to do, I'll work out QR first. To get from Q to R, I'll have to go QP, then PO, then OR. Q to P is minus 4B, minus 4A, plus 12B. 12B take away 4B is 8B. 8B minus 4A. I can now use that road if I want to. I'm trying to prove ultimately that XY is parallel to OR. All right, so I can now use these roads. So let's work out XY. To get from X to Y, I'm going to go X to M, M to Q, and then Q to Y. XM, well that's, I'm going only halfway along the road MN, which I worked out in the last question, but also the wrong way. I'm sort of going against the grain here, aren't I? I've worked out how to go from M to N, and now I'm trying to go backwards along it. So that's only minus a half of what I worked out last time, this one here. M to Q on my diagram already, 2B, and then to get from Q to Y, that's only half as much as the jump QR, which I've just worked out. That was a little bit of inspiration because I've done hundreds of these in my life. I know I was trying to work out XY, but I knew that QR was going to be kind of handy in the process, so I worked it out first. That just comes with experience. There's nothing wrong with diving in with XY first, and you might pretty soon realise that, oh, hang on, I better quickly work out QR first to help me. And okay, so no problem there. Let's simplify this then. So that is minus 2B, minus here, careful, makes plus 2A, plus 2B, that's 4B, that's minus 2A. And what you might notice then is that the A's cancel out. I've got plus 2A minus 2A, minus 2B plus 2B. It's just 4B. Okay, it just ends up being 4B, which is great. I have now proved, well, I need to make the statement. I have proven that XY is parallel to OR because I've got that XY is only 1/3 of OR. Remember, OR is given, it's actually up here, isn't it? So it's gone off the edge of the page. OR is given up here as 12B. So what I've established then with this particular set of workings is that XY is only 1/3 of that. I've been able to write one vector is a multiple of another vector, and therefore I've got that XY is parallel to OR. And I'm done. Okay, finally part C is asking us, could PZ and R be collinear? And I put Z on there because we're told that Z divides the line MN in the ratio 1:3. So we've got the one part there and the 3 parts here. I don't know if Z is exactly here, but I mean, if PZ and R stands a chance of being a straight line, then it's got to be roughly here. Okay, let's work out a pair then. You've got choices. You could work out PZ and ZR. You could work out PZ and PR. You could work out ZR and PR. Totally up to you, all right? Let's work out PZ. Okay, it looks like a little easy jump. So let's do PZ. To get from P to Z then, I think I'll go P to M and then M to Z. P to M I know as being 2B. And M to Z is only a quarter of the MN, which we worked out at the very beginning, which is just under here. And it was 4B minus 4A. Okay, it's 1/4 because if Z splits the line in the ratio 1 part to 3 parts, then the whole line is 4 parts, isn't it? 1 part there, 3 parts there, 4 parts in total. So the little jump from M to Z is 1/4 of the whole jump, M to N. Let's simplify this then. So 2B plus, that's 1B, and that's minus 1A. I make that 3B minus A. Brilliant. So I've got one of the pairs sorted out. I've done P to Z. Maybe let's do P to R. I mean, I've got P to R already, haven't I? So what was P to R? I worked it out earlier. No, I haven't got P to R. Let's do P to R. So I'll go PO and OR. P to O minus 4A. I'm going backwards along A. That's 12 B's. I think I prefer that the other way around. I'd rather have that as 12B minus 4A. Oh, look at that. This one here is 4 times bigger than this one here. Right, if you times this one by 4, you get this one. Or alternatively, this one's 1/4 of the size as this one. So I'm going to say now then that PR is just 4 lots of PZ. Therefore, PR is parallel to PZ and shares the point P. Therefore, P, Z, and R are indeed collinear. And we didn't know that in advance. It's perfectly possible that you could be asked the question, are they collinear? And the answer is no. So if you'd done this and that one wasn't an exact multiple of that one, then the answer would be no. They're not even parallel, for example.